Now we're going to take a look at vertical shrinks. We looked at vertical flips. Now we're going to see what happens when the graph shrinks. First of all, we're going to look at f of x equals 1/2 times x squared. Notice the 1/2 is not in parentheses like the horizontal. That would be a horizontal stretch. It's outside of the total function x squared. So what happens? So here we have our parent function p of x equals x squared. Now watch what happens when we make a equal to 1/2. Okay, the graph actually. Now here's what's confusing for some people. Yes, it did horizontally stretch, but it also vertically shrunk. The y values went down. If you take any y value on the parent graph, you've got to move down to reach the green. So sometimes it just takes looking at the transformation in a different way. You can see those y values go down. The only one that didn't go down is 0, but we'll talk about that in a second. So why do the y values shrink in half? And in fact, they do shrink in half. For example, p of 3 is equal to 9, right? What is f of 3? And whoops, I had the wrong a value. It should be 0.5. Let's try this one more time. Okay. p of 3 is equal to 9. f of 3 is equal to 4.5. It's half of that, right? How about p of 2 is 4? F of 2 is equal to 2. It's half of 4. So it shrinks in half. It shrinks how you would think it would shrink for vertical. Why? Because you're just taking the y values and multiplying them by half. Again, vertical transformations are a lot easier to understand than horizontal. Let's do 1/2 x cubed and 1/2 absolute value of x. So if we do 1/2 x cubed, here's the original. This one's a little bit harder to see, but here's the original y values. The new y values you can see are actually cut in half. For example, p of 2 is 8, f of 2 is 4. Now on the flip side, for the negative x values, p of negative 2 is negative 8, but you still cut it in half to get negative 4 for your f value. So it's still cut in half because there's a 0.5 or a 1/2 in front of the x cubed. Same thing is going to happen to absolute value of x. Here's a y value, for example. You have to cut it in half to get the new y value for the f of x, the green function. So it's just straightforward. You're just cutting the y values in half. That's all you're doing. We can see that when a is equal to 1/2, the parent graph shrinks vertically, but why? Going back to our x squared function, we know p of 1 is equal to 1 squared, which is 1. Well, if we put a 1/2 out front, we're obviously going to be taking that y value and cutting it in half. I mean, it's just that simple. You're just taking the y values and halving them because there's a 1/2 here. We could do the same thing for p of 2. p of 2 is equal to 4. If my transformed function was 1/2 x squared, I'm just going to take that initial y value, p value, and just cut it in half. So my new y value is half 2 of the original y value of 4. And that's my vertical shrink. I had vertical flip. Oh, I had this one vertical flip too. Let's change that. Since I did change them, it brings up an important point. Yes, you can have a shrink and a flip, but for right now they're just shrinking, and you're going to see why. Whenever a is less than 1, the graph will shrink by that much. In this case, it's shrinking by 1/2. And again, when we plug in 2, we get 4, and when we plug in 2 to our transform function, we get half of that because of this 1/2 right now. Now, in general, when a is equal to 1/2, all of the y values are going to shrink by half because x squared is just p of x. So you're just halving whatever that p of x value is, and that will give you your vertical shrink of a half. It has to do with order operations too. You would always square something before you cut it in half, right? You'd always take the square root before you cut it in half. You would always take the sine of it first. You're going to evaluate the function before you multiply by that scalar. The proof for this is very simple. So suppose f of x is equal to 1/2 p of x. For example, f of x equals 1/2 x squared, where p of x is x squared. You're just going to flip the equation, and ultimately to find the y values for f, just take the original p of x values and multiply by 1/2. In other words, the y values of p of x are shrunk by a factor of 1/2 to reach the y values of f of x. It's very simple. Here's our x squared chart. We've looked at this a lot. There's our normal x values, -2 through 2. To get the new y value for f of x, just take your p-values. Again, for vertical transformations, the y values change, the x values stay the same. Take all of your p-values, multiply them by half, since your a is equal to 1/2, to get your new y value. So now we have 4 times a half is 2, 1 times a half is 0.5, 0 times a half is 0, so on and so forth. These are our transformed f values, function values. And the final chart looks like this. Again, the x values stay the same, the y values are cut in half because it's 1/2 x squared. Here's what that final graph looks like, and as you can see, for example, p of 3 was 9. We didn't do p of 3, I'm sorry. This is do p of 1. P of 1 is 1, and we have to cut that y value in half to get our new function value. F of 1 is equal to 1/2. And so on and so forth. That's it for this video. If you have any questions about it, let me know.